In Creo 12, you can create a flat assembly from a multibody part. If you select bodies, you can invoke the command create an assembly from bodies from the bodies context menu. Alternatively, you can access the save as assembly command from the file menu to create a part from each of the bodies and assemble the created parts into a new assembly. After you invoke the command, you can define the file name of the new assembly and immediately complete the command, or review additional options in the Advanced Options user interface. Here you see all bodies listed in the same structure as in the design tree. By default, construction bodies are excluded. You can define a new file name for each part manually, or use the familiar file name generation tools based on a template, prefix, and/or suffix. Various options are available to define the templates for the created parts. You can control the default settings for the update control and propagated properties for the data sharing feature if the corresponding licenses are available. Here we set the update control to manual with notification. The type of the data sharing feature being used depends on the body type. For regular solid bodies, an external copy geometry feature is used in the created part. For bodies of type sheet metal, the default method uses inheritance features. After the completion of the command, the new assembly is created, containing a new part for each of the selected bodies. The new parts contain an external copy geometry feature that copies the corresponding body geometry into the new part. As illustrated, the update control settings are taken over from the previous definition. Let's go back to the multibody source model and make a geometric change to the side surfaces of the green body. Switching to the new assembly, we get the notification that the corresponding external copy geometry feature is outdated and can invoke the update command to propagate the geometric change. The second example illustrates the process for a sheet metal design with a multibody skeleton model of an enclosure design. When you use the save as assembly command on this design, you will see that the default data sharing type for bodies of type sheet metal is set to inheritance by default. Additionally, you can then also define a sheet metal specific template part. After the new subassembly is created, we can assemble it into our original assembly and hide the original master model skeleton part. In this sheet metal case, the created part will contain an external inheritance feature followed by a remove body feature that isolates the selected body. You can then create the regular flat pattern feature and flat representations or flat instances. Finally, you can also restructure the newly created assembly and parts. Overall, this increases design productivity through faster creation of an assembly from a multi-body master model. Previously, this required many manual and repetitive steps.